All right, so here's a compound inequality. Is this an and or an or inequality? Are there two separate ones that split off like the oars of a boat, or is there one sandwiched in between numbers like a sandwich? It's a sandwich. It's an and, right? So when you have an and inequality, what you're going to do is you're just going to solve for the x in the middle by undoing all the operations on all parts. So you have three different parts here, right? Part 1, middle part, and the right part. So you're going to isolate the variable in the middle by performing the same operation to all parts. So we undo the order of operations. Add 5 first. And to get rid of this 5. So that leaves us a negative 4 is less than or equal to negative 4x, which is less than 8. And now what do we have to do to get the x completely alone? Undo the multiplying by dividing. So when we divide by negative 4, we get 1, we get x, and we get negative 2. Now, what happens in an inequality when you multiply or divide by a negative number? You flip the symbols, and that includes this. You have to flip the symbols in both of these. Okay. So when you write your answer, I'd like you to always write it in the order that those numbers appear on a number line. So put the smallest number to the left and the larger number to the right. So negative 2 is smaller, 1 is larger. And so when you reorder these for between negative 2 and x, does the inequality open to the x or open to the negative 2? Opens to the x. So you're just going to rewrite it so it opens to the x. And then between the 1 and the x, does the inequality open to the x or to the 1? Opens to the 1. So here is your inequality form. Second.
Why did you put the negative 2 first?
Because you want to write it in the order that it appears on a number line. The furthest point to the left first, and then the furthest point to the right second. Okay. So the graphic form of this, the graphic notation, has a critical point at negative 2, a critical point at 1. Okay. Is it going to be the set between them or the set extending outside of each? It's an and, so it is sandwiched. So we're going to take the numbers in between these are your solution set. Is negative 2 included in that set? Is there equal to in this inequality? No, so it's a parentheses. And is 1 included in the set? Yeah, it has the equal to, so it's a bracket. So here's your graphical notation. And so your final step would be the interval notation. And you just you can copy what you have right here. Lower limit negative 2, upper limit 1, negative 2 not included, 1 included. And so this would be the interval notation for that. Okay. I want you to try one on your own. Okay. And I want you to find all three forms of it. All right, if you're continuing to work, what I want to do is show you how to use your calculator for this. Again, it's available to you. And you may need to check. I don't know if the one online will actually do this because it requires a certain operating system. So if you are connected to the calculator online, you may want to try and see, will this solve inequalities for you? I don't know that the operating system online is updated enough to handle.
Oh, it does.
It does it? Okay, perfect. And so you can solve these inequalities, the compound inequalities, on your calculator as well. So if you just type in what you have, remember you can use the green diamond for the less than or equal to. Tell it what you're solving for. And you get your solution, which is negative 3 is less than x, which is less than or equal to 2. So here's your interval notation. The graphical form has critical points at negative 3 and 2. Will there be a bracket or parentheses at negative 3? Parentheses, no equal to on the inequality. Will there be a bracket or parentheses at 2? Bracket. And again, you have this compound inequality with the and form. It's sandwiched in between. So our solution set will be sandwiched as well Okay, so here's our graphical notation. And then the final form is the interval notation. And you just take your lower limit, -3, upper limit 2, and put the appropriate grouping symbols. Parentheses indicates exclusion. It's not included in the set. 2 is included. And so that would be your interval notation. Okay. All right, I'll do that.
Wait, not now, but
Not now.
We'll do that tomorrow.
I'm still working on something.
Okay, so let's, Eileen, question
How'd you get 2?
on the solution.
Yeah.
I trusted a calculator, but I can go through the steps here.
So 17 minus 8 is 9.
Uh-huh.
yeah.
Then divided by -3, right?
And then you've -3, right? And then you've switched the order. So you probably had 2 is greater than or equal to x, which is greater than -3.
Yeah.
And then, but write the lower number first. So that way you can, it models what it looks like on the number line.
Okay.
Jonathan?
Okay, so when you divide the x's,
Yes.
and then you switch the signs, and then you flip it over, so it would be like -3 would be first.
Right, so-
Signs also come back.
So here's, if you solve this by hand, you got, this is what you would get, and when you subtract 8 and divide by -3. And then, because the -3 is smaller than 2, it should come to the, be written to the left of 2. So you just reorder it. Put the -3 here and the 2 here, and then just orient the inequality symbols. It's opening toward the 2, so open this one toward the 2. Here it's opening toward the x between those two terms. Nick? Okay. Let me write the next problem off and take a look at that. Okay, let's take a look at what happens with the OR inequalities. Okay. When you're given an OR inequality, you are going to be provided with 2 separate inequalities. So here they're not sandwiched. They're 2 separate ones. And you're just going to go through the steps of solving them individually. And so go ahead and see if you can solve this set. Second weekend. All right, so let's take a look at this. Okay, if you work through this by hand, we look to isolate each variable. So subtract a 1 from both sides. We get 5x is less than -5. Divide by 5. We get x is less than -1. Do we need to flip the symbol? No, because it's only if you multiply or divide by a negative number. It doesn't matter what your product or quotient equals. It's just what if you multiply or divide by the negative. In the second example, or the second part of this, again we isolate our variable by adding 2 this time, and then dividing by 6. We get x is greater than or equal to 2. So you know that you have this OR set up. So your intervals are going to have 2 critical numbers, -1 and 2. We expect it to split out. Okay, so let's see if that's true for what we have. X is less than -1, so everything less than is to the left, so that's true. And is there a parentheses or bracket here? Parentheses because it's not included, there's no equal to. At the critical point of 2, x is greater than that, so all the points that are greater than fall to the right, and it's a bracket. And so here's your graphical notation, here's your interval or your inequality notation. In this one, you'll actually use the word OR to separate them. Okay, and then your final interval notation, you're going to write the intervals for the left part, followed by the interval for the right part. So for the left part, our lower limit is -infinity, our upper limit, -1. Can never include -infinity. Our -1's not included either. So it's a parentheses. And then on the right side, we have a lower limit of 2, an upper limit of +infinity. 2 is included. Infinity can never be included. And because we're taking the union of these 2 sets, there's 2 intervals, we'll use the U to designate that connection. It means union of sets. It means that you'll have two interval sets that are solutions.